Some of my students have been asking for more examples of test-driven development, and as we talked about what kind of examples would be useful, they thought it might be interesting to take something from an earlier class and rebuild it using TDD rather than trying to learn TDD while also learning something new. So here I've put together a very simple specification for a linked list, the kind of thing you might see in a CS2 or data structures course. This is not a fully featured linked list. This is just a subset of features that would be fairly useful for a linked list. Now, the obvious caveat here is that you should never, under any circumstances, write your own linked list class. You should use the one that's given to you by the Java libraries, but this is really just a pedagogic example. So, given this as my list, my task list, I'm going to go ahead and jump in by saying my lists start out as empty. Let's do this. So I've got my basic project set up here. I'm going to make a new test class. We'll call this linked list test, and get rid of that. Alright, so my first test will be initial list is empty. That's fine. So I want to be able to make a linked list, and I'll say list. I think the way that I specified it is to say the size is 0. It would be pretty easy to add a isEmpty method, but let me just do size is 0. List.size. We'll say assert, oops, 0, list.size. There we go. Now this wants to bring in java.util.linked-list, of course, but what we're going to do is create a new class, and we want to make sure that it's going in our source folder. It is. So there we go. Get rid of some of this cruft. Let's see. So to bring in assert, we're going to mark this as a test, of course. Alt-Enter, add to class path. Yep, good. And import this. Great. Now there's no size method, so put in that. And we'll use the default implementation for now, which turns out to be correct for us for right now. So there. That gives me a state where everything compiles. Let's go ahead and run all the tests. Great, no problem. Remember red, green, refactor? We really didn't have a red step here because we were greenfielding this. We didn't have any code. And our default implementation happened to be correct. But we should still refactor. So let's take a look and see if these names are okay. I like size as a name. That's pretty conventional. Even though it's not really a verb phrase, it is pretty conventional. Over here, I think I'm going to switch over and use something more like Google's Java naming conventions. Say test the method I'm testing, and then describe the test that way. I like that better for now. We can always change our minds later. So again, just double check, run these tests. Great. Okay, next case. If we add a, the size is 1. I wasn't planning on using version control, but it feels really weird to me not to commit this. So let's go ahead and set up a quick repository here too. Yeah, that's cool. Because now we can go over here, we can shove all the stuff into version control, and we can commit this and call this the initial commit. That's fine. And let's see, does it know who I am? Nope. Good. I'll commit that. Oh, let's review. Yeah, go ahead and add that. Oh, this is my my old nemesis, this new warning that was added recently to IntelliJ IDEA. Boy, I don't like it. What kind of options do I have here? I just want that to be public. Let's see. Let's just disable that inspection. And yeah, so that's going to modify some of this configuration files. We'll just say OK there. Great. I'll run these tests again. All right, everything's good. And again, we'll go to Git, and well, let's do it from here. Yep, let's go ahead and commit those. It remembers that. It doesn't remember this, but we can put that in and commit. Oh, yeah, this is actually my first time using Git on this machine, so better do this. we want to set that globally, yeah, that's fine. Cool. All right, I feel a little more stable now that I have version control under me. All right, back to here. If we add a to the list, then the size is 1. I neglected to say what this is a list of. Is it a list of strings? Maybe we should go ahead and make it generic. That'd be pretty fun. Let's see. So public void test. Let's see, what's that case again? If we add a, the size is 1. So test size 1 element size is 1. That might be a little wordy, but it's okay. All right, so if we make a linked list, and then we assert dot, we're going to have to add something to that list. So say list dot add a, and then assert dot assert equals size is 1. All right, so this doesn't compile. We're going to have to add that method. Alt-Enter will do that. Good. Back over here. Right, so this compiles, and we can run all our tests, and we should get red. Good. That's where we want to start, is our test makes sense. It might need to be refactored, but that's okay. It still makes sense. We are at red. Now we know how to make this test pass. Let's see. Again, we get some options here about what's the minimum amount of code that we could use to make this work. Let's do this. There, keep track of how many things are in the list. Run the tests. Good, we're at green. Now we can get into refactoring, which one thing I can see here is we have a compiler warning. Parameter A is never used. It's true. In fact, we don't need it right now. But at the same time, I'm not sure we're gaining much by not actually implementing this. I mean, we could remove the parameter, or we could actually add some real implementation, which I think is what I'm going to do instead. So let's do that. A linked list is a series of nodes that are connected to each other, so I think the easiest way for me to do that is going to be to make a private class node. We still haven't dealt with the type here. Let's do that. So we can say this is going to be a list of t. We'll call that value node head first, I guess. So this node is going to have a private t in it. That looks okay. There's going to be a link, but we don't need that yet. So let's just go with this here. And then we can say first is going to be a new node. There. Now, I'm not dealing with what if there's already something in the list, because I don't really need to yet. But now I'm actually using this parameter, so I feel a little better about that. Again, there's multiple ways to get through this, but this is okay for now. Let's see what this warning is. It's assigned but never accessed. These compiler warnings are useful, but when you're doing TDD, one little step at a time, sometimes you want to just pretend they're not there, which I think is what I'm going to do in this case. Just ignore that warning for now, because I'm going to have to solve that real soon. Similarly, value here is never used. Yeah, but we're going to use it soon enough. So I think I'm going to be happy with that. Again, knowing I'm taking kind of 1.5 steps here, but because these steps are still pretty small and I got version control under me, I'm not going to worry about it. I can always amend my commits too. So let's see, unchecked call to add t as a member of raw type. Because this is now going to be a linked list of strings. I think I can use the diamond operator here and it'll infer the type. Yeah. Okay, let's run these tests. Good, I didn't break anything. So let me do a little bit more careful refactoring, but maybe around some of those warnings I don't want to deal with. Here, this can definitely be pulled out. And here, and we can make ourselves a list here. And what I want to do is use a before method. and this would just be giving us a new linked list each time. That way my tests are all independent of each other. Back over here, looking for things that I want to refactor, but ignoring the fact that some of these things aren't quite used yet. I think this is good enough. So again, after refactoring, always run those tests. That looks okay. Let's go ahead and do that. So this will be add the add method. Only cover adding the first element. Now I'm not too worried about this message because I'm planning on amending this commit. I'm not going. This commit really has no value except if I royally screw things up and need to revert back to it. Let's bring in my name and commit that. Okay. So let's look at that to-do list again. The next thing I have is that you can get the first thing out of the list. So let's go ahead and go to there. It's going to be here. Test get one element. That's fine. So if I have a given a list that has one thing in it, if I say list.get 0, the first thing in the list, then expected value is A, actual value is result. I've got to get this to compile, so we'll use the old Alt-Enter trick. That's fine. We'll call this index maybe. All right. So if I take this default implementation, it should fail because my comparison fails, right? Expected A but was null. So let's write just enough code to make that work. We can say first.get, that's not right, first.value, right? Which should work actually. That's cool. What warnings are left here? Parameter index is never used. Now again, this is a case where I think I'm just going to ignore that warning for now, knowing that this is little baby steps. Let me go back here and look for refactoring opportunities. I don't really like the fact that this is here, and it's hard to distinguish between the setup code and the the code we're testing. So I'm going to rename. I'm going to make a method here that makes it more clear. Given a list with one element A, and this is just a wrapper around. Not around that. Around list.add A, and that's going to be value. So I did that because there's this conventional format, which you may or may not have heard of, called given, when, then. Some people abbreviate it GWT, which is confusing if you also use Google Web Toolkit. But the idea is every test has a given section, so your sort of your preconditions, what are you setting up ahead of time. When is what you're actually doing, and then is what you want to check. So given a list with one element, when I get the first element out, then this is my result. And I could wrap this in a method called when I get the first element, and I could wrap this in a method called then this is what I find, but I'm not so worried about that. I think that this gets me close enough to what I want to see here. Again, your mileage may vary, right? You can refactor this differently. This is just okay for now. All right, so as promised, let's just oops, no, I don't want to revert. Here, let's just amend that old commit. I don't think I've ever used that control space before. That's pretty cool. So let's change this to add, and get methods that work only for one element. Lists. Okay. Good. I find myself thinking, if I really had to write this, would I be taking such small steps? I don't know. That's an interesting question. But really, since this is more of a pedagogic example, I don't mind these little steps. One of my favorite properties of test-driven development is that you can define your own step size. So, all right, back over here. If B is added to the list that contains A, the size is 2. All right. This will be test size. So B add second element is sort of what we're doing. So we'll say this is, now again, I can use this method, again, that sets up a precondition, an initial state. And what I want to do is say list.add B. Then I can say assert equals 2 is going to be list.size. Oops. All right, that should fail. Ooh. Oh, yeah, no, actually it works because our add method is manipulating size. Okay, that was a freebie, I guess. What were the warnings over here? Yeah, index is never used. Oh, yeah, just index is never used. Again, I'm just kind of ignoring those for now because this is all just part of one work session of squashing commits. All right, good. Next case, I guess. The first element should still be A, so let's do that. So let's see. Now I guess I want to say given a list with 2 elements, A and B. Maybe I'm taking too many steps here. You can see where I'm going, right? You saw how I refactored that other one out. I'm just going to give myself a little utility method to do that work for me. Assert equals. Oh, I gotta have that get, right? List.get 0. This will be string result. So my expected value will be A. That's the actual value. All right. So again, I'm just using this to hide some of the ugliness of the setup. And in fact, I'll just use variable arguments here. And we can say for every string s in elements, add s to it. Easy. And in fact, then we can rename this right away. Yeah, so you caught me. I'm refactoring, even though I haven't, not in the refactor step yet, right? I should do red, green refactor. Sorry. Okay. Given a list containing A and B, the first thing should be A. All right, let's run it. Good failure. Right, and this is because our add method is really not doing the right thing here. So let's take the simplest implementation I can think of, which would be to just walk the list to its end. So we can do something like this. While temp, oops. As long as the next field is not equal to null, then we can do temp equals temp.next. Real standard linked list operation. Of course, I don't have a next field. We'll stick that in here. That'll be initialized to null, so that's fine. This has to go. No, the problem is that first can be null if we're just starting out, right? Let's just do this directly, and we can always refactor it later. If first is null, then we just say first is a new node containing the value. Otherwise, we'll do all this, and then say temp.next is new node value. Is that it? Oh, my test passes anyway. So let's look for refactoring opportunities, right? Red, green, refactor. One thing I thought of is that we don't need this anymore, because now we have given a list containing. Given a list containing. Okay. So over here, I don't care for the size of this add method. I don't like the fact that we're handling kind of two different states. Either first is null, we do one thing, otherwise we do this other kind of thing. And I'm reminded from my old days in my data structures courses talking about the advantages and disadvantages of dummy header nodes, so you don't have to do this kind of logic. But this is not a presentation about data structure trade-offs. It's really just about TDD. So I'm going to leave it like this for now. That'll be okay. We still have this warning, which is from the get method, which again, we're just going to sit on for now. So that's good. We're going to grab a name, amend the commit. We add so now we have the add and get methods, and we'll mention here that get does not work for lists with more than one element yet. And there may be other problems too. That's okay. All right, back to the to-do list. I do like having these on paper so I can cross them off, but that's hard to show in a video. I want to make sure that one is B. Good, because our add method adds to the end. So let's just copy this. How's that? I'm reminded of the step-down principle from clean code. So while I'm here, I'm going to plop that up to the first place it's used. Okay. All right, so we have a list containing A and B. We want to get 1, and the result should be B. And this should fail. Good. So now we get to go in and make get work the way that it should, in the same way that previously we made add work the way that it should. So let's see, what's the easiest way to do this? If index is 0, we could return first.value. Let's see, we can't really do this recursively through the nodes. So let's just let's grab a pointer to the let's see, if we start this at first and we just count index down to 0 and move the node to next each time, that should get us there. While index is greater than 0. And this makes me think about the fact that in my my task list here, I didn't really deal with invalid inputs, like what happens if I try to add null, what happens if I try to get the negative third element. But again, like I said, this is not a fully featured list. This is just showing some TDD. And hopefully this gives you a good spine on which you could build out your own cases, to handle exceptional cases. What happens if you get something that's not there? Try to call get 0 on an empty list, for example. Anyway, you see where I'm going with that. You can try it. All right, back to the task at hand. While index is greater than 0, we can reduce the index and say node equals node dot next. And then we should be able to just return node.value. Yeah, cool. These algorithms that I learned 20 years ago, they still work. Again, if that's confusing to you, check some sources on data structures. I'm just interested in showing the test structure here. Let's look for refactoring opportunities. I did clean up some of the names, and I moved that method. I have a couple that have the same given, but that's okay with me. I don't feel like I need to pull that out into a whole different test suite. Yeah, I'm okay with this. Some people would say, well, those two are too similar. You could make a parameterized test out of it. I don't think anybody really would. It's a straw man argument. But I'm reminded of something I read in the Pragmatic Programmers, where they say when you copy something once, so you have two copies of it, or two instances of it, you just sort of grin and bear it. And then when you have a third one, then you look at really improving the result, the structure. I don't know. I guess it's a matter of taste at some point, or a matter of what your company pays you to do, I guess. So back to the task list. We got that done. Let's say given the list A and B, remove the first one, and the removed thing is A. Okay, so removal is a brand new function for us. Oh, did I commit that? No, I better commit that because I think that sort of completes this train of thought of the add and the get methods. To be fully confident, maybe we should have a couple more test cases, but I really think that we've covered these. I think that's okay. So I'm going to go ahead and amend that commit for the last time. Now I'm going to think about this differently. In retrospect, maybe that was a good example to show feature branching, but again, I don't want to conflate too many ideas in one video. So let's test our next thing. Test remove first element from two-element list. Element was the first. So given a list containing A and B, my result is going to be list.remove A. So I'm using kind of a common protocol here where when I remove an element, it changes the list, but also returns the thing that was removed. So it's sort of a combination of remove and get, the other way around, combination of get and remove. Sometimes that's useful when you're using a list. All right, pardon me. Good, that should fail. Let's make it pass. So, let's see, let's call this, wait a minute. That's not what I wanted, is it? You watching at home knew. That should be 0. So I'm doing this by index, not by value. Again, you could add removal by value as to build on this. Hard to say one thing and type another. All right. So we want to remove something at that index. Let's double check here that this fails. Yep. Good. We're at red. Let's get to green. So we'll say return first.value. Actually, that's probably enough to make this pass. It's certainly not correct, but it passes. And to triangulate towards this, I think I like that. You know what? And because I mentioned feature branching, let me just let me do it. So this will be my remove branch, and let's go ahead and commit this on here. And we'll say, I wish this would remember my name. Add remove method that doesn't work properly. We're going to squash that later. All right. So I should have checked for refactoring opportunities, but this is so broken right now. Let's see. Let's make it work better. So we want to see the size is 1 when we're done here. Let's see. Oop, test. Test remove, and this is really the same kind of case here. But I want to say that now the size is 1. So we'll do these operations and then say 1 is list.size. Cool. Good. Good. Right, because this is obviously completely wrong, but now we have to deal with that. Again, simplest thing to do would be to do that, and that makes it work, and it's only 1 line of code, and my tests all pass, which means there's a real sense in which this is correct for what we've defined as correctness. So in that spirit, let's roll with it. I don't need to hold on to the thing I'm removing. That looks okay. Let's do this. That's good enough for now, because I'm going to amend this again once I get this in place. So last case is, if I call get 0, it should be B, and this is going to be where the remove method really has to shine. So let's see. Maybe a little verbose, but that's okay. This will be B if we say list.get0, which again should fail. Good. Good. Let's make it pass. So now I have to deal with actual removal, right? Because otherwise this is just not going to work. So how do we do that? Again, we were going to run into this problem that I don't have a dummy head node, so we're going to have two different cases, probably. Let's see. If index, we could count the index down. You know, now that I think about these test cases, I missed something really important. Removing the last element. Anyway, that's all right. I'm not going to lose sleep over that because this is really just showing TDD for the cases I have here. I didn't even record myself doing the requirements analysis, right? Figuring out what tests have to go here. And now that I said that out loud, I think that's where a lot of my students tend to struggle. I think implementing the tests is not so hard compared to figuring out what tests should you have. But let me stay in the spirit of this video. So we can say node is going to be first while index is greater than 0. We'll do index minus minus and node equals node dot next. This should point node at the one we want to remove, but we also need the one before that. So this is going to be that start at null, and there we go. So now we've got this prev pointer that's going to walk right behind the node pointer, so that node points to the one to remove, prev points to its predecessor, and when we find it, right, when index reaches 0, then we can say, oh, this is where we have to deal with this awful if prev is null case. If prev is null, that means index must have been 0, and so now we're going to say first is node.next, double equal, obviously. Otherwise, the previous was not null, or previous is not null, and so we can say prev.next equals node.next. Yeah, that looks like the right idea. Let's try it. Yeah, it's been a few years, but I can still write a linked list. How about that? And this might sound really silly, but I haven't written code like this in almost 20 years. And I miss dummy head nodes already. Man, those are really fun. And circular linked lists, so cool. These singly linked lists, they're for the birds. Anyway, the point was to show TDD, and so I should stop talking and start refactoring. So let's see, red-green refactor. Now this is where things get tricky, right? I explained what all these are, but is it clear from the code? Let me call this predecessor. I feel like in a lot of the textbook code that I remember seeing, they just call this prev. I feel like that has a semantics loaded with it, but I haven't taught data structures in 15 years, more actually. So what's going on here? This is actually counting the index down. It's tempting to pull that into a new method, but I would have to send in node and previous, so that's more trouble than it's worth. Yeah, I think what we're having here, thinking about things like clean code rules, I think what we see here is an artifact of a bad data structure design. If I had a nice dummy head node, all the rest of this would be much cleaner. So I think I might just live with this for now. You know, my students know that I have this kind of 4-line principle. If I have a method that's more than 4 lines, I look at it really carefully to see if I can chop it down. Um, but in this case, I think this is about as small as it can be, especially if I'm tracking size as a separate field. Or there's a sense in which size is doubly represented. Right? The size is both in the data structure and being stored in the size field. If I dynamically computed the size, I wouldn't need this call on line 36. I wouldn't need the call on line 13, and I wouldn't have a redundancy. I don't like that redundancy. I'm going to take that out. If it gets to be a bottleneck, we'll fix it then. In the meantime, we can do the same kind of logic here to say the count can start at 0, and we can say while node equals first, while node is not equal to null, add to the count, node is node dot next. All right, again, classic linked list stuff. Return the count. Cool. Oh, what's the warning up here? Oh, size is never used. Yeah, good. Look at that. We have improved the cohesion of this class. Now there's only one field, first, and it's used in every method. And this is, of course, a separate class. This could be final. That's all right. All right, so refactoring-wise, I feel pretty good about that. Let's again look at these tests. I guess we do have kind of similar setup multiple times. But I'm not sure I want to write a method called when I remove the first element just to replace that. You know, what would it look like? When the first element is removed. I mean, if you wanted to do it, all right, there it is. And then I'll use it again here, so I can get that cool given, when, then. And you know, the same principle applies here. You know, if you really like that, you could say, then the size is 0. And this just reads like a script. And if you get into behavior-driven development, BDD, which is kind of a cousin to TDD, you'll see a lot more of this. But for now, I think this is good enough. Again, what's the point of this video? It's just to show how we could take a simple CS2 style problem, underspecified, and start walking through it using TDD. If you were to really have to write a linked list using TDD, you'd have to spend a little bit more time with this, I think, to make sure that all of your critical cases are covered. But hopefully this gives you enough that you could build on it if you like. I'd be really curious what you think about this video, so feel free to leave a comment, or if you're in my class, tell me about it. Thanks for watching. I was about to publish this video, and then I realized I never actually merged the feature branch back in. I got so excited talking about other things that I almost forgot. So let's wrap this all up properly. Here we go. So this is going to be another amended commit. Add the remove method. Good. So again, this is amending on the feature branch, where I can go to the log here and see that I've got my initial commit, and then I've got this behavior, or this feature added on master, and then over here, and my head is my remove feature branch. Let's merge that in. So I'm going to switch back to master, and then I'm going to select the remove branch, and I'm going to merge it. So I'm probably out of my screen capture area, but I'm clicking on merge, and that's it. So now I can delete this remove branch, and master shows this clean history of 3 commits. The fact that I used the feature branch is gone, but I had all the security of knowing that if things went really badly, I could just blow up that branch. So there, that's my real conclusion. Thanks for watching.